everyone. A lot of people have been asking how to solve these types of problems when it comes to probability. So if I have a box with 7 tickets, 3 of them are shaded, 4 are not shaded, and I ask you, what's the probability of drawing at least one shaded ticket if I draw 3 times, and then we want to specify with replacement? Okay, so the way that we're going to do this, the way that we talked about in class, is by looking at the complement. At least one is one of our 2 special cases where it's easier to look at the complement rather than just solving this directly. We talked about complements on the first day of probability. We said that the probability of something occurring plus the probability of something not occurring gives you all of your options. It equals 1 or 100%. So something occurring and something not occurring are complements because when you add them together you get 100%. So we can think about that for at least one. If I think about getting at least one shaded ticket, if I'm drawing 3 times, well, that means that I can either get 0 shaded tickets, right? I could draw 3 times out of this box and get all non-shaded ones. Or I could also get 1 shaded ticket, right? That's another option. And I have more options, right? If I'm drawing 3 times, I could get 2 shaded tickets. And then lastly, I could get lucky all 3 times and actually get the 3 shaded tickets when I draw out of here. And these are all of my options, right? So all of these together gives me 100%. And what we want to do is figure out, okay, which of these fall into the category of at least one. So we can ask ourselves, 0 shaded tickets, is that at least 1 shaded ticket? No, right? That's 0. That's none. 1 shaded ticket? Yep, that's at least 1. 2 shaded tickets, that's also at least 1. And 3 shaded tickets, that's also at least 1. So all of these fall under the category of at least 1 shaded ticket. All right, so we can see if I wanted to calculate this directly, I'd have to calculate 3 different probabilities and add them together. Instead, I can make my life easier and say, well, I know that the only thing that's missing from at least 1 is none, is 0 shaded tickets. So this is none. All right, so at least 1 and none are complements because when I take all of them, I get all the possible options that I can get. And if I calculate this probability, I can just take 1 or 100% minus that to get the probability of at least 1. So that's where the rule comes from. So what I'm going to do is say that the probability of getting at least 1 shaded ticket is equal to 1 minus the probability of none, or in this case of getting no shaded tickets. All right, and we can use this rule whenever we're asked about the probability of at least 1. It makes our lives easier. At least 1 is usually more difficult to calculate, as we can see from this diagram up here. So what I'm going to do is just take 1, you can just leave your answer like this, 1 minus, and then just focus on this probability. What's the probability that I draw 3 times with replacement and get no shaded tickets? Well, think about it draw by draw, right? If I'm drawing 3 times, I'm going to multiply 3 different probabilities together. So on the first draw, I want to get a non-shaded one. And so I have it looks like there's 4 non-shaded ones out of 7. I have a 4 out of 7 chance of getting a non-shaded one. So say I got this one, I took it out, and it's with replacement, so I'm going to put it back in. So the probability doesn't change for the second and the third draws. So I can leave my final answer like this. I can write it like this if I want to. 1 minus 4 out of 7 cubed. That means the same thing, and that's how I calculate the probability of at least 1. Our second special case is the probability of not getting all shaded tickets. So this is another instance where it's going to be easier to look at the complement. If I ask you, if I draw out of this box, same box, 3 times with replacement, what's the probability I do not get all shaded tickets? we can do the same thing that we did before for at least one. I can say, all right, well, if I'm drawing 3 times, here are my options, right? I can get 0 shaded tickets, like we said before. I can get 1 shaded. I can get 2 shaded. And lastly, I can get 3 shaded. And those are my only options, right? So I want to figure out which of these constitute not getting all shaded tickets. And I can go through again and say, all right, 0 shaded, is that not getting all shaded? Yeah, that makes sense, right? 0 is not all. If I'm drawing 3 times, is getting 1 shaded not all shaded? Yes. Same with 2 shaded, that's not all shaded. The only thing that doesn't encompass the not all is getting all 3 shaded. So it makes sense. These 3 options represent not getting all shaded. And then the only one we're left with at the end is getting all 3 shaded. So not all plus all gives me 100%, or 1. So we can see not all and all are complements, right? Just like at least 1 and none are complements. And if we wanted to calculate not all directly, again, we'd have to calculate 3 different probabilities. It gets confusing, especially the more times you draw. So what I can do is say, all right, well, the probability of not getting all shaded is just 1 minus the probability of getting all shaded. And this makes my life easier because now, instead of calculating this complicated probability, I can just take 1 minus the probability of all. All 3 shaded is just going to be, so I have 1 minus the probability of all 3 shaded. Again, I'm going to multiply 3 different probabilities together. I would look at my box and say, okay, on my first draw, what's the chance I get a shaded ticket? Well, there's 3 of them out of 7 total tickets, so that's just 3 out of 7. And again, it's with replacement, so that probability isn't going to change. If I get this shaded one on my first draw, I'm going to put it back in so that I still have 3 out of 7 shaded ones on my second draw and my third draw. So this right here, I can leave it like that, or I can simplify it to 1 minus 3 out of 7 cubed. Either way, that's your final answer. All right, so the last point I wanted to make here is just the fact that if we ask you what's the probability of not getting all shaded and what's the probability of getting no shaded, those are 2 different questions. A lot of times people will think not all and none mean the same thing, but if you think about an example, you'll realize they're actually 2 very different questions. So not all is the probability we just calculated, right? We said that's one of our special cases where it's easier to look at 1 minus the complement, which is the probability of all, okay? If I asked you what's the probability of drawing 3 times with replacement and getting no shaded tickets, well, here, we don't have to do, this isn't one of our special cases, we can just calculate this directly. We can just say, okay, on my first draw, what's the chance that I do not get a shaded ticket? 4, right, out of 7. And if I'm drawing with replacement, I'll take my non-shaded, the first draw, put it back in, and then my next probability is still just 4 out of 7. And same with the last one. So none, essentially, what's the probability of none, can just be calculated directly. The only thing that I'm looking at here is getting 0 shaded tickets, right? That's the only thing that falls under the category of no shaded or none. But with not all, we said before, not all, that means sure we could get 0 shaded, right? I'm drawing 3 times. Or getting 1 shaded ticket is technically not all. And same with even getting 2 shaded tickets. That's not all. The only thing that isn't encompassed in not all is all. Hence why we look at that to when we're finding the probability. We look at the complement. So none and not all are different. Think about the example. If you tell your parents, I got no A's this semester versus I didn't get all A's this semester. You're saying two different things, right? The first one means you got no A's, 0 A's, all other grades besides A's. The second one is saying, you know, you might have gotten, if you're taking 5 classes and you didn't get all A's, maybe you still got 4 A's, you just didn't get all 5 A's. So make sure to understand that difference between not all and none.